Hello everyone, welcome to Mechanical Sati. Today here we are going to discuss 10 important MCQs from Thermodynamics. So this is the third lecture in the MCQ section. So before this already we have uploaded two videos on this. So if you have not watched those two videos, then you can find them from the playlist of Thermodynamics, and otherwise I can attach those links in the description box of this video, so you can find them from here also. So without wasting time, let us move forward and start our discussion for today. So for this first question is that what is the which of the following is true for a closed system. So we know that there are basically three types of systems available. One is your open, another one is your closed, another one is your isolated. So if we'll discuss that, in case of your open system, both mass and energy were that can be transferred. Okay, so open, in case of your open system, both mass and energy can be transferred. Okay, and but in case of your closed system, mass cannot be transferred from the system or into the system. So, and in case of your isolated system, none of this mass or energy can be transferred. So for this question, that is question number 1, we can say that so options are here given, that option A is telling that mass entering will be equal to mass leaving. It can't be the answer, because mass interaction is not taking place in case of your closed system. So there will be no interaction of mass. So we can say A cannot be the answer. Second option is telling that mass doesn't enter or leave the system. So this option can be the correct answer. So let us check all other options also. So mass entering can be more or less than the mass leaving. So this option is also wrong. And D option is telling that none of the mentioned. So it cannot be the answer also. So here we can see B option will be the correct answer. Now let us move towards question number 2. So that is so let us read it. So a piston cylinder contains air at 600 kilopascal. Temperature is given 290 Kelvin and a volume of that is 0.01 meter cube. So volume at that initial condition, it is also given, that is 0.01 meter cube. So a constant pressure process gives 54 kilojoule of work output. So process is given as constant pressure, and work is obtained from the system, that is given as 54 kilojoule. And find the final volume of air. So we need to find out the final volume of air over here. So if you will be trying to find out what are the given data over here. So here I can write this is pressure at inlet condition, so that is P1, and this is temperature, so this is T1, and this is volume, that is B1, and the work which is being obtained from the system, that is given W out, and the process which is obtained, that is constant pressure. Okay, and we need to find out final volume, so that I can write that is V2. Okay, so we need to find out the V2 over here. So during constant pressure process, and here it is a piston cylinder arrangement, so we can say that this is a closed system. Okay, so this is a closed system and pressure is remaining constant over here. So if we'll be trying to find out the work done in a closed system and during the constant pressure process, so I can write W out will be equal to pressure, okay, P dV. Okay, so let this is 1 to 2. So integration of P dV from 1 to 2, that will be giving me the W out, that what will be the work done from the system. So here W out is given to us, and constant pressure process, so P is also given to us, so we can write P1 will be equal to P2. So pressure will remains constant, so P we can replace by your what is given, that is 600 kilopascal, and dv I can write after integrating, so that I can write p into v2 minus v1. Okay, so v1 is given to us, p also is given to us, and w out is also given to us. So w out can be replaced by this 54 kilojoule, and v2 we need to find out. P is given as 600 kilopascal, v1 is given as 0.01 meter cube, and from this there is only single unknown, that is v2, and we can find out this the value of v2. So that can be calculated as 0.01 meter cube. So try to calculate this value, so you can find out to this answer. So this answer you can calculate, that is as 0.10 meter cube. So now let us move towards next question, that is question number 3. So see here, so which of the following represents the steady flow energy equation? So if I will try to write the steady flow energy equation, so I can write like this, that is h1 plus v1 square by 2 plus gz1 plus q, that will be equal to h2, okay, sorry, that is 2 plus v2 square by 2 plus gz2 plus w. So let us try to find out our with which option it is matching. So let us try to know that. So if I'll be seeing the option A, then q plus wx, and so here you can say q is in this side and w is in this side. So q plus w can never be done. Okay, so from here we can see both option A and option B cannot be our answer. So now let us check option C. So q minus wx, both C and D may be the answer. So now let us try to check all other parts. So now if we'll check, then in this both the options, that is C and D, w is taken into this side and this whole term is taken to this side. Okay, so now I can say q minus w, which will be equal to what, that is h2 minus 1 h1. So these two options are also correct, and next term we need to check, that is here it is given, that is minus v2 minus v1 whole into v2 plus v1. So these two term will give me, that is v2 square minus v1 square. Okay, so these two will combinedly give me this one, and from here also I am getting this one. But now thing is that here I need to deduct that v2 square minus v1 square, and v2 must be positive in this case. So here C option cannot be the answer. So here I can say that D option will be matching with this. And let us try to check the third term also. So third term will be equal to what, G, and G will be taken common, and Z2 minus Z1. So here we can say our D option will be the correct answer. So now let us check it. So here we can say that is D option will be the correct answer. Then let us move towards the next question, that is question number 4. So now let us read this question, that is question number 4. Okay, so a balloon containing an ideal gas is initially kept in an evacuated room and insulated room. So that room is unevacuated and insulated. That means there will be no heat transfer, and there will, we can say that there will be no work transfer. Okay, so the balloon ruptures and the gas fills up for the entire room. So that balloon ruptures inside that room, so that whatever gas will be inside that volume, that will fills that room. Okay, and which one of the following statement is true in this case? Okay, so if we'll be seeing here that in this case there will be no heat transfer as well as there will be no work transfer. Okay, so as there is no heat transfer and there is no work transfer, so it will be considering this is as a process that ruptures of that balloon is as a process. Then during that process I can say there will be no heat transfer as well as there will be no work transfer. So according to first law of thermodynamics, if you will see, then your d, okay, so dq will be equal to what, du plus d, okay, that is dw. Okay, and if these two terms are 0, then we can say this du is also 0, and if this is 0, then we can say this is what, this is that u is equal to constant, that we can say that u2 minus u1 is equal to 0, that from here we can write u2 will be equal to u1. So I can say during this process your internal energy remains constant. Okay, so another thing, if u is remaining constant, then I can say the temperature also remains constant. Okay, because du we can, sorry, that is exact differential. So okay, so if du is equal to 0 and here du I can write it like so, let me write it over here. So du is equal to 0, then I can write cv dt. So du we know that is cv dt, so cv dt is equal to 0, so this is a constant term, so this is constant, and dt will be equal to also 0 here. Okay, so cv cannot be 0, so here I can say dt will be equal to 0. So if dt is equal to 0, then I can write t1 will be equal to t2. Okay, so if dt is equal to 0, then in terms of enthalpy, so we know that dh is equal to what, cp dt. Okay, and if in this case also dh is equal to cp dt, that we know, and dt already it is equal to 0, from here already we know that. So again here also we can say dh will be equal to 0, so from here we can say h will be equal to constant, that means enthalpy will also remain as constant. So let us check all these options over here, what is matching with our answer. So the internal energy of the gas decreases from its initial value, so it is not decreasing, and enthalpy remains constant, so that is the correct one, but it is not decreasing. The internal energy gas increases, so it is not also increasing. So both internal energy and the enthalpy gas remains constant. Okay, so both the internal energy and enthalpy of the gas remains constant, so C option will be the correct answer. And let us check the option D also, so that is both internal energy and enthalpy gas increase, so option C will be the correct answer. So now let us move towards next question, that is question number 5. So the equation of continuity comes from which? Okay, so already we know about the equation of that is continuity, and this is the conservation of mass. So from the conservation of mass we can find out the equation of continuity. So I think you know about the conservation of mass, that means we can say mass flow in. Okay, so flow, so suppose there is any flow, this is a control volume concept, open system, and whatever mass is taking into the system, that amount of mass is going out from that system. Okay, from that control volume, suppose we have considered that this is as a control volume. So control volume we mark by using this dashed line. So if we have considered that this is as the control volume, then whatever mass is taking entry into the system, that amount of mass will should leave the system. So that is known as your conservation of mass. And from the this conservation of mass principle only, we have derived the equation of continuity. And equation of continuity we can write as your a1b1 will be equal to constant, and we can write the rho also if it is any compressible system, if it is not compressible, that is incompressible, then we can also neglect this row. So we can write down like this is a1 b1 equal to constant. Okay, that is ab, multiplication of your a, that is where a is the cross-sectional area and b is the velocity. Okay, so velocity of the flow velocity. Okay, so from here we can see that option B will be the correct answer, that is the conservation of mass. Then moving towards next question, that is question number 6. So let us read it. For an ideal gas with constant values of specific heats, okay, so specific heat remains constant for the calculation of specific enthalpy. Okay, then which option will be the correct answer? So both temperature and pressure are required to be known. So basically it is asking to find out the specific enthalpy if your constant values of specific heats are known to us, then what other parameter is required to us that we need to find out. Okay, so if we know the value of a specific heat, that specific heat at constant pressure, so we know that let me, already I have told you that if we need to find out the enthalpy, okay, so dH, then I should know the Cp value and dt. Okay, so likewise, if I want to find out enthalpy at a certain state, that let this is at that condition, that point 1, at point 1 we need to find out the value of enthalpy. Then how can I find out? The value of Cp will be multiplied with the temperature at that point. Okay, let this is T1. Then if I know only the temperature at that state, then I can find out the value of enthalpy. So if I know the value of specific heat, then only I require the value of temperature. So let us check all the options over here with which our answer is matching. So if we will see, then option D, it is sufficient to know only the temperature, that will be the correct answer. So in this case, your option D will be the correct answer. Okay, so now let us move towards next question, that is question number 7. So the exergy of a fluid at higher temperature is dash than that of the lower temperature. Okay, so the exergy of a fluid at a higher temperature is dash than that at a lower temperature. So what is the value of exergy at a higher temperature at compared to lower temperature? So we know that amount of work done, exergy is what? The minimum, that is the maximum amount of work that can be taken from the from any system. Okay, so if our system is at higher temperature, okay, then we can get the maximum work from that. So obviously we can say the exergy of a fluid at a higher temperature will be more. So option A and option D are that those two options cannot be the answer. So we are left with B and C. So among these two, our answer will be only one. So let us check another statement. And as the temperature and dash as the temperature decreases. So obviously when temperature decreases in any system, then exergy available at that point, that exergy or maximum minimum, okay, that work available at that system will be also decreased. So we can say that here C option is matching with our answer, that is the exergy of a fluid at a higher temperature is more than that at a lower temperature, and it decreases as the temperature decreases. Obviously C option will be the correct answer. So now let us move towards next question, that is question number 8. Let us read this question, that is question number 8. So which one of the following pairs of equations describe an irreversible heat engine? So from the second law of thermodynamics, according to the Clausius statement, so if we will see, so this okay, so del Q by T must be less than or equal to 0 for any feasibility cycle. So feasibility for the feasibility case, it should be less than 0 or equal to 0. So if it is equal to 0, then we can say this is a reversible engine, and if it is less than 0, then we can say this is this is an irreversible engine. And to be an irreversible engine, that del q, integration of del q must be greater than 0. So here we can say option 1 will be the correct answer. Then let us move towards next question. So let us check it, and we can see option 1 is the correct. Then moving towards next question, that is question number 9. The maximum theoretical work obtainable when a system interacts to equilibrium with a reference environment is called what? So already we have discussed about this. So maximum theoretical work obtainable from any system when it will be contacting or communicating with a reference environment, that is called as your exergy. Okay, otherwise it can be called as your also available energy. Okay, so option C will be the correct answer over here. So we can check it. C will be the correct answer. So now let us move towards next question, that is question number 10. So if a closed system is undergoing an irreversible process, then the entropy of the system will what? So if any closed system is undergoing an irreversible process, then entropy of the system may increase or decrease or remains constant. So we can say here D option will be the correct one. So because it is a closed system and it is an irreversible process, so if we can consider the case of reversible process, in that case we can say your entropy remains constant, because integration of according to the Clausius statement, integration of del q by t will be equal to 0. But in this case of your what, that is irreversible process, and as this is a closed system, your that your what in case of irreversible process, that entropy may increase or decrease or remains constant. So we can say option D will be the correct answer in this case. Okay, so with this we have reached at the end of lecture for today. So if you are new here, then do subscribe it and press on the bell icon, so that you will be getting all the notifications from our channel. And do share this with your friends who are preparing for different exams, different mechanical oriented exams. Okay, so thank you for watching.